Okay, we're recording now, so I'll be very careful about what I say.
Wait, where's 01? On page P4.
Page P4.
So laptop's over there.
Chapter 0, Section 1.
I thought you put a laptop over there.
Not yet.
That one's not ready yet. Right now, the Elmo is recording. It's only going to record what's on the screen right here. It just recorded my hand. And it records all the volume that it can pick up, all the audio. Right. In Section 1 of Chapter 0, changing units of measure within systems. I'm not going to spend a whole lot of time on this because we're not going to be required to do a whole lot. But here's what I am going to say. Here's what you need to know. You need to know that there are 12 inches in 1 foot. 12 inches in 1 foot. There are 3 feet in 1 yard. 12 inches in 1 foot, 3 feet in a yard. That's because sometimes we will be given measures like, Susie's got a piece of material that is 3.5 feet long. And she's got another piece of material that is 26 inches long. Altogether, how much material does she have? If she put them together, how much material would she have?
Well, 26 divided by 12 is 2, 1, 2. So about 5.
Not about, exactly.
Like 5 inches. 5
Look,
and...
I like where you're going. Automatically you picked up, hey, I've got to convert those inches to feet.
Could you all put it all in inches?
That would be the better way to go is inches. Change
68.
it all to inches, and then change it to feet once you get the final answer.
Yeah.
So how many inches is 3.5 feet? How many inches are in 3 feet?
42.
How many inches are in 3 feet?
30. No, 40. Hold on. 33 feet.
3 feet. 36. Now how many inches
42.
are in a half a foot?
46. 42.
Okay, I know. You all keep shouting out 42, and there's some of us that don't understand where that number came from.
Sorry.
Okay, so in 3 feet, there's 36 inches. And in half a foot, there is 6 inches. So 3.5 foot is 42 inches. Plus 26 inches. 58 inches. That might be good enough for the answer.
It's 68.
Right, 68. Yeah, thank you. 68 inches. Right. Now I'm going to throw a wrench at it. How much would that be exactly in feet and inches? That's not exactly in feet and
You
inches.
should put an answer and get 5 more inches.
Okay, so how many whole feet?
5 whole feet.
5 whole feet. All right. 4, 5. Here's the symbol for feet. How much would you left?
8 inches.
8 inches. If you can count by 12s, this becomes a lot easier. 12, 24, 36, 48, 60. I counted 12 5 times, so that's 5 feet. I don't have enough left in that number to go another 12. So 5 whole feet, 60 inches. Trent, I need you to pick your head up. And beyond that, I have 8. So 5 feet and 8 inches. Normally, when we're converting from one unit of measure to another, we use a scale factor. If I have inches and I need to convert to feet, then I have to come up with, okay, what's the relation between those two? And we've already talked about 1 foot equals 12 inches. There's my ratio. Okay. 1 foot, 12 inches. No, that equals 1. No, this is a ratio.
Oh.
A ratio. Okay, I've set this ratio up to be able to convert a measure. I can use it in this order, or I can flip it upside down and I can write 12 inches over 1 foot. Landon? Here's how I determine which way I want to flip this ratio. Whatever answer I need, if I need my answer in inches, then inches go on top. If I need my answer in feet, then feet go on top. Let's go back to, let's take 48 inches and convert it to feet. Now we already know what it is, but let's see how it becomes that. I'm going to convert 48 inches to feet. Here's my conversion rate, my ratio. I need my answer in feet, so the feet part of this is going to be on top. So 1 foot, 12 inches. Now I start with the measurement that I have, 48 inches. It's not a fraction, so I need to make it a fraction. 48 over 1. So 48 inches over 1.
2.
Hang on. Now, if you do it correctly, here's what's going to happen first off. In math, when you're multiplying with fractions, if you're multiplying, you get to cancel on the diagonal or reduce on the diagonal. So right here, inches and inches cancel out. Now my answer is going to be in feet. The feet doesn't get canceled out. Are you okay, Shani? Mm-hmm. I can do more reducing before I multiply, or I can go ahead and multiply and then reduce. If I multiply, it's the top times the top, so 48 times 1 is 48 feet. And on the bottom, 1 times 12 is 12. And then in your calculator, you do 48 divided by 12. 4 feet. We converted 48 inches to feet, and 48 inches is in fact 4 feet. Let's do one the other way. Let's do feet to inches. Okay, so if I'm going to change a measure in feet to inches, what do I need to write down first?
Huh?
If I'm going to convert a measurement in feet to a measurement in inches, then what do I first need to start with?
The inches are
Finding out how many.
Right, I need to use this same scale factor, only I need the inches on top. Since my answer I want in inches, that's what I put on top of the fraction, the inches part. Alright, so 12 inches and 1 foot. So 13 feet is what I'm converting to inches. Now what? Trent, get your head up. Now what?
You cancel out the diagonals, so you won't have feet more.
Cancel out the feet.
And then you multiply.
Okay, so 13 times 12.
156.
156 inches over 1, so 156 inches. For the most part, this is the type of converting that we will be doing. There won't be a whole lot, there won't be any, really, of changing from metric to standard, standards to metric. I don't even know why that was in the assessment. Yeah. So regardless of what you're changing, and you might have to do multiple stages. Using units of measure between systems. That's what we just got through talking about. Simple probability. If you want to know how likely an event is to happen, it's the number of positive outcomes divided by the total number of possible outcomes. If we're talking about experimental probability, then we really do it like, what's the experimental probability that a person in this room will be male? Male. So how many events in this room would be a positive?
Well, there's 1,
It's
2,
4 out of 10.
4, 3, 4.
Oh,
Four males in this
Got you,
room.
Ricky.
How many total people in this room? 10? So the experimental probability that a person in this room will be male will be 4 out of 10. This will reduce 2 out of 5. This is 4, 2, 5. Whoop whoop! Algebraic expressions. This is section 04.
Yeah, I love
This is not algebra.
it. This is geometry now. We're big
I
kids.
know.
Oh.
Huh.
Can you believe
Oh.
it?
Okay, let me get this on camera.
Yeah.
Okay. Let's see here. Hi. Hello. How are you? All right. Okay. Well, I just want more algebra. That is so cool. Oh, sorry. Okay. In geometry. Here's how much algebra we use. Here's how much geometry we use.
Yeah, I don't think algebra was that important.
So we don't use that much geometry?
So why do we need this class?
Okay.
Here's the task that's going to be laid in front of you in every single thing that we do. You'll have to look and analyze. That's the geometry part. Where do I start this process to get that answer? What you'll be using to get the answer
gosh, yay!
Yeah!
Yes, sir.
I'm gonna have to go home and watch this video.
Did you hear what Skylar said? Yeah.
Yeah.
Oh, why did they make us use calculators? I want to use my brain. Shut up. I want to use this section to reiterate that every time they give you an example, it's going to look exactly like your work. Addition, subtraction, algebraic expressions. Well, this one made me a liar. Multiplication, division, algebraic expressions. If this were in a regular chapter that we were doing, then we would flip over to the exercises, and it would say addition, subtraction, algebraic expressions. This is P10.
Oh, I got mine.
Let's see. Absolute value. We're not going to be into absolute value very soon. And so we will reserve going into length on this right now. But this is just a case of plugging in the values and working it out. What did absolute value mean?
Not positive matter. It's how far it is from zero.
Right, it's a distance. So distance is always positive. Even if you end up with a negative answer on the inside of the absolute value symbol, it's going to be a positive number.
So absolute value is how far away you are from zero.
Correct, on the number line.
Look right there. Someone get rid of that thing. That would scare me. That's literally the only level to
Goes around, right?
For the roach.
Go, Mr. Mackey. Yes, sir. Saving my life. One crawled under my foot this morning when I was getting ready, and let me tell you, I lost it. Just kill it. Don't sell it in the trash can.
That would be very rude. He's dying either way.
No, she's gonna mess it up.
Oh wait, I thought you threw him in the trash.
Put it on the hallway. I think that's not called back up in here. Thrown it.
You didn't just say what I did.
No, like,
Man, I was 5 minutes late to school. Mr. Gallimore tried to tell me I was an hour and a half late. It was still first period.
Yesterday.
dude, I think that's
Okay, quiet. Linear equations. What does it mean by linear equations?
Linear means like, like a straight line, right? Equal.
Line. Linear.
Line,
It means
yeah.
a line. A
Like,
line.
It's linear.
Line.
linear, yeah.
Linear. Multiplication, division, linear equations. That's just solving equations, which you know how to do. Linear inequalities. More of the same. Ordered pairs. It's just a point. Alright, system of linear equations. This is the part that really threw some of you all for a loop. We have multiple ways to solve a system of linear equations. Now you would ask me, and I would just tell you, I would remind you what the methods were and not tell you how to do the methods, because that's kind of giving you the answer. Because the pre-assessment is to see what you remember, not how well you can follow what I tell you right there.
I forgot how to do that.
No, you didn't.
I did. I couldn't get like any of them. I did all the graphing stuff, but whenever it went to the y equals something, and you had to like solve that. I was like, okay.
Yeah. I knew I got them all on. I kept doing it.
I did not even know what to do, so I was just like,
Alright, here's a system of linear equations. This particular system is set up perfectly for us to use graphing to get the answer.
oh, I hate that.
Okay? Now there are steps that we have to remember, but the first part of it is just graphic. Tanner?
Oh
Open
my
them
gosh,
eyes.
I remember how to do that now with the calculator. Oh my gosh.
So turn your calculator on, then what do you do after that?
I'm
Y
so
equals.
dumb. You
So
go
Y
get
equals.
Y equals.
Oh.
I just remember.
I hate it.
Man, I am mad now, Mr. Mackey.
Hey.
Is that X
You
minus
got
5?
mine.
I could have gotten all of those right.
Alright, this is y equals 7x plus 3, and then y equals x minus 5.
And then you go to.
Hold on, I'm
Wait,
not
what are
there
we
yet.
typing?
Alright,
Where you typing it in?
7x
Jesus.
plus 3, x minus 5.
Oh yeah, I know.
Type it in, Tanner. Trent? Type it in. Landon? Now with your pencil, where's your calculator?
I got it. 5.
I don't have one.
Yep, ma'am.
Well, rad.
Turn it on.
Linear. Y equals 2.
It's
Mr. Mackey, I'm kind of upset right now.
7x plus 3 and x minus 5. Have you used these calculators, Tanner?
This one is. And then you go to second graph, right?
Second
Oh, no.
trace.
Second trace. Okay.
5x. Like that.
Mm-hmm.
Alright.
Alright, so, what? So, Aubrey, you started, so what are the steps?
Second trace.
Second, and then go up there, push the trace button at the top.
And then you press 5.
5.
And then you let it load for a minute.
Yeah, wait until you see writing at the bottom of the
And
screen.
then enter.
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 3 times?
Yep,
There's your intersection.
there's your
Like
intersection.
that means always one solution because it's not for a little.
Yes.
Yes, always 3 times.
If I would have just sat there and my brain would have worked, I would have gotten all of those right because literally all you do is type it onto a calculator.
Yep.
My dumb self.
I got it wrong.
It's okay. Don't worry.
You can't leave class to go back.
I was talking to
Okay.
me. I was like, I didn't ask those after.
If you've got an emergency, you need to go to the restroom, then you just need to get up and go, and then when you're done, go tell Miss Pam why you left.
You're going down there?
I got something different than what you got.
You must have entered it wrong.
There he is.
I did, probably.
Samuel.
Better.
You're better. You're still kind of.
Yeah, it's just my usual ones. I thought I was interested in that. See how old it is.
No, we're still mad.
Okay.
Look.
Oh, I'll put that in. When y'all do that,
Okay, now, that worked, and we could do that because of the way that both of these were set up. They were both set up as y equals.
But then you have times where it's not y equals.
That's right,
Then you
so,
have to solve it and make it equal before you can
so y equals
stay on to its line.
x plus 2.
really.
And then 3x plus y equals, hang on,
Where you get
let me
that
think for a minute,
I'm making it up.
7.
I don't know.
I thought he was like,
You want me to put that in my calculator?
No. You can't put that in your calculator.
you know, boy, it has to be y equals. You have to solve it
Oh,
now.
I can put the x plus 2 in there.
You subtract the 3x from
Mhm.
that side.
Well, you have options.
And then
You can either solve this second equation so that it starts out with y equals, or you use substitution.
That takes way too long.
It's-
It's just easier, like if you subtract the 3x from the y side and put it
Okay.
on the other side of the 7.
So
That's what I mean.
you can do that. If you're going to use substitution, y equals this. So you take the y out and replace it with x plus 2. So 3x plus x plus 2 equals 7.
you combine everything.
4x plus 2 equals 7. 4x equals 5. X equals 5 over 4.
Bro, what?
that?
And then you would go back and you would replace the x right here with 5 over 4. We're just talking about how to do it. I'm not expecting you to do it right now. So we did graphing, we did substitution.
Where did you come up with that from? I thought you were just supposed to subtract the 3x from that side, and then just move it on to the side with the 7, and
Okay.
then y equals 7 minus 3x.
That's the way you would do it if you wanted to use graphing.
That's just
But
a
to
different way
use
to do it.
substitution, this is the way you do it. You have to substitute something in and then solve the equation.
So my way would still work, right?
Mhm. And then there were those that looked like this.
I don't like these ones.
Ah,
They're not pretty.
you see one.
They are very ugly. Carl.
Okay, this is elimination. Elimination, where you're going to eliminate one of the variables.
Isn't eliminating basically subtracting?
Yes.
You either use adding or subtracting to get rid of it. Okay, so to use elimination, then you decide, do I want to get rid of the x's or the y's? Neither one of them match up. In other words, this doesn't say 3x like that one does. This one doesn't say 5y like that one does. So you get to pick then which one you want to get rid of.
3 small.
The x's?
Yeah.
Right. So to do that, we've got to multiply this whole equation by 3. That would give us 3x, 3y, and negative 12. And you're going to subtract. 3x, take away 3x, that makes the x's go away. And then 5, take away 3. Five, take away 3. Yes, Molly, it's 2. Thank you.
Good job, Molly.
2y.
Proud of you.
2, take away negative 12. 2 take away negative 12.
That's 14.
Positive 14. Divide
And
by
then you
2.
divide by 2, and then you get y equals 7.
No.
Bam.
No.
Now that you know how much y is.
Oh.
I'm sorry. Now that you know how much y is, you plug it back into one of the equations and you solve for x.
Can we do a run through for that?
Hmm?
Can we do a run through with that?
You can, but now I'm going to show you how we did it. We did it with our calculator. When both
Yeah, that's the
equations are set
matrix.
up in standard form, what did you say?
The matrix.
Matrix.
I was trying to figure it out yesterday and I didn't get it. Figured out.
Marxism.
You go to second and then the x with the negative 1 exponent dealing. It says matrix right with it. It's right under the math button.
So here's what we started with right there.
You get 1.
These two equations. There are 2 equations, and each equation has 3 terms. So it's going to be a 2 by 3 matrix. It's always a 2 by 3 matrix for algebra.
That would work. Let's form a union.
So here's matrix. It's right below the math button. It's in blue. So we push second on that button. Landon. We use all 3 of these headings, but we're going to do them in reverse order.
You have to go to edit.
Go to edit, push enter, 2 equations, 3 terms. So it's 2, enter, 3, enter. Tanner, I need you to do this. Trent, I need you to do this. Are you right here?
Oh my goodness, I have to go swear. You go second. Matrix. Scroll over to edit.
Do this last week.
Hmm?
And then 2 times 3. Scroll over to edit. Scroll over to edit, bud.
I don't know.
And then
Exactly what I did.
It never fails. What? It never fails.
Now,
Y'all get it?
what are we going to type in? Here's our 2 equations right here.
It's always in that order, right?
Oh.
X, Y, and then the number.
It's not, but we need to do them in the same order.
Then you'll type 1, -4, first one.
Okay. That's because in the first equation there's 1x, 1y, and the constant -4. So
And then 3,
1,
5,
enter, 1, enter, -4, enter.
Wait, what? Oh, because you don't have a. Oh, okay.
Remember now?
Yes, now I remember. Because there's only you don't have a placeholder for X or Y, so there's only one for the economy, right?
Yeah.
Yeah.
All right, now, Aubrey, you're doing good, but let somebody else answer this. What do you type in for the second equation?
3, 5, and 2.
3, enter, 5, enter, 2, enter. There are 3 x's, 5 y's, and the constant 2. So 3, 5, 2.
It's been a while since we've done this.
Alright. So we're done building the matrix. We just need to do some operations now, but we want our calculator to save it and let us use it. How do you do that?
You hit second matrix again.
No.
That's what I did. Is that A?
Second mode. Second mode.
And then you go back to the matrix.
Mm-hmm.
Yeah.
Second, and then x
And
to
then
the
you go to
negative
math.
1. Go to math. Slow down because for some of us it's brand new.
Or I will go to on that.
Okay, to get to what we need under the math heading, it's actually going to be faster to scroll up, and it's right here. It's option B, RREF. Okay.
Go to math. Now press math.
Okay, we can't just hit enter now. We have to put in the name of a matrix that we want it to solve for us. It's waiting. So second matrix again. Option number 1 is matrix A. It's already highlighted, so just push enter and then enter again. So in our equations, the x came first, then the y. X plus y equals whatever that number was. So here's our 2 answers, all the way out here at the end.
X equals
X
-11.
is
Y
negative
equals
11,
7.
and y is 7.
such if you forget which one is which. Do that.
Yeah. Put it away. Okay. Last year we practiced it both ways, so you had both of those tools. You either do it by hand, by subtracting the two equations and solving for each variable, or you remembered, hey, I go to matrix and I do it that way. You can still, on these equations, solve them both for y. Stick them into y equals, do second, trace, 5, wait, enter, and it will still work. All right. Look, I'm going to need effort from everyone. Mr. Evans may be visiting with some of you all later. Just find out if anything's going on. I need you in class.
Why did we
I
put
need you participating.
Why did we put the two? Like I'm writing down nothing. But why did we put the 2 times 3 on the matrix part? Like whenever you clicked over to edit,
Because there's 2 equations, 3 numbers in each equation.
Sucker is wiped out.